So this lesson is on slope. So let's start with the definition. The slope of a line describes the steepness of that line. So some examples. Slope can be really steep, like this one. Or slope can be flatter, like this one, not as steep. These you do need to know, so I would maybe put them in your notes somewhere. Positive slope goes up, so this is a positive slope. Negative slopes go down. A horizontal line, a line that goes straight across, that slope is 0. And if you have a vertical line that goes up and down, that slope is undefined. Okay, you do need to know those 4 slopes. Okay, this also you should write down. This is how we find the slope when you're given 2 ordered pairs. Slope is m. Here's what I mean. I'm sure this year you've seen this equation, y equals mx plus b. M, this number right here, is your slope. That's what m stands for. So whenever you see the letter m, that means slope. It's also sometimes stated as rise over run. I know you've heard that. And then this is the equation that we're going to use to find the slope from 2 ordered pairs. y2 minus y1 over x2 minus x1. So let's do some examples. If you'll write down these 2 ordered pairs, pause it, and then when you come back, we'll work it out. All right, so ordered pairs always go x's and y's. That's an ordered pair, x and y. X comes first, y comes second. And you label your first ordered pair with 1's, and you label your second ordered pair with 2's. And now it's pretty easy. I'm going to take this equation, and I'm just going to plug in what I know. So what number did I label as y2 up here? It's right here. I labeled y2 as a 1. Then I'm going to put my minus sign. Then I'm looking for y1. So out of these 4 numbers, which one did I label y1? Well, it's right here. It's negative 2. I'm going to draw my division sign. On the bottom, I'm looking for x2. x2 is right here. It was negative 4. Minus x1. x1 is right here. It is negative 1. So let's talk about typing this in your calculator. Make sure if you wrote down a negative that you're typing in a negative. So let's look at what I wrote. On top I have 1 minus negative 2, so it's going to look like that, and you get 3. Then we're going to do the bottom. On the bottom I got negative 4 minus negative 1. So that's what it should look like when you type in the bottom. And I hit enter and I get negative 3. And then your last step is to actually divide those. So we're going to do 3 divided by negative 3. And my slope is negative 1. Now, some things that means. It's a negative number, right? Which means it's going to go down. Negative slopes means it goes down. And if we were going to plot this, it means technically you would go down 1 and over 1, down 1 and over 1, down 1 and over 1. All right, let's do another one. Write this one down. Again, I always like to just start by labeling them. Ordered pairs are x's and y's, x's and y's. I'm going to put a 1 on my first ordered pair. I'm going to put a 2 on my second ordered pair. So again, I'm just taking this formula and I'm going to plug in what I know. So start up here. y2 was 4 minus y1, which was 2. Draw my division sign on bottom. x2 was 3 minus x1 was negative 1. On top, 4 minus 2. I don't need my calculator for that. I know that's 2. Let's do the bottom one on the calculator. I got 3 minus negative 1, and that is 4. My last step is to actually do that division. 2 divided by 4. And that gives me 0.5. Now, something you need to know about slope. You always want to change slope to a fraction. So remember, you hit math, enter, enter. So this slope is 1/2. When you're doing slope, put it in a fraction if possible. All right, here's another one. Label them x's and y's, x's and y's. First one gets 1s, second one gets 2s. Let's plug them into this equation that I have. y2 is 2, y1 is 2. On bottom, x2 is -1, x1 is 1. On top, 2 minus 2, I know that is 0. On bottom, if you typed it in the calculator, you would get -2. Last step is to divide these. 0 divided by -2 is 0. So the slope of these two ordered pairs is 0. If 0 is on top, your slope is 0. Okay, what about like this? Look, they gave me a graph, but they also gave me the two ordered pairs on this graph. This ordered pair is at 0, 2. This ordered pair is at 7, 3. So it works the same way. I'm going to label this x and y, and this x and y. This one's going to get 1s. This one's going to get 2s. So again, my formula was y2 minus y1 over x2 minus x1. So let's plug in. What did I label y2? 3 minus y1 was 2. On bottom, x2 was 7 minus x1 was 0. 3 on top, 3 minus 2 is 1. On bottom, 7 minus 0 is 7. Let's divide them. 1 divided by 7. It's a long decimal. Again, change it to a fraction. Hit math. Enter, enter. And 1 over 7 just reduces to 1/7. So I want you to pause it. I want you guys to actually try this one. See if you can get the right answer. Okay, hopefully you attempted it. I'm going to put x and y. X and y. Some of you might be saying, does it make a difference which one I put the 1s on and which one I put the 2s on? It does not. You could have done this one as x2 and y2 and this one as x1, y1. It doesn't make a difference. So my formula y2 is 2 minus y1 is 6. x2 is 4 minus x1 is -1. 2 minus 6 is -4. 4 minus -1 is 5. Last step, we're going to divide them. -4 divided by 5 is -0.8. We don't want that though. We want it as a fraction. So I'm going to hit math, enter, enter. And it is -4/5. Which makes sense because look at this line. This line is going down, which means my slope should be negative. And here, I got a positive answer, which again makes sense because my slope is going up. All right, this one I don't want you to try by yourself. I'm going to do this one with you. Again, I got an x1 and a y1 and an x2 and a y2. So let's plug in. On top, y2 minus y1, 3 minus -2. On bottom, x2 minus x1. So on top I have 5. On bottom, 1 minus 1 is 0. Let's go to our calculator and divide that. 5 divided by 0. Whoa, it says error, divide by 0, because that's not allowed in math. You cannot divide by 0. So if 0 is in the denominator, that means your slope is undefined. This is one of those lines that went vertical. And look, if I plotted these, 1, -2, and 1, 3, these two dots do make a vertical line, which is undefined. So what I want you to write down, if 0 is on top, like if I had 0 over 5, then the slope is 0. If 0 is on bottom, then the slope is undefined. So if 0 is on top, your slope is 0. If 0 is on bottom, it is undefined. If you forget, it's not a big deal. Your calculator will always tell you. Because if you try to do 0 divided by 5, you get 0. It will tell you when the answer is 0. But if you try and type in where 0 is on the bottom, it's always going to tell you there's an error. And that's how you know that the slope is undefined. All right, what do you do if you get a graph and it doesn't give you the ordered pairs? Well, it's pretty easy. You're going to find 2 points where that graph crosses, okay? And it has to cross a grid. So like it would have to go right here where 2 grids cross, or here where 2 grids cross. Like I'm not going to pick this point right here because it doesn't cross at 2 grids, right? But I could pick this one. I'm going to erase this one so that we don't get confused. So I'm going to pick this one, and I'm going to pick this one. Now, I'm going to show you some more that you could pick because there are actually quite a few on this graph. We could also pick this one because it crosses at 2 grids. We could also pick this one because it crosses at 2 grids. We could have also picked this one because it crosses at 2 grids. Okay, so it doesn't matter which 2 points you pick as long as they cross at a grid, okay? And as long as you know how to write the ordered pair for that point, okay? So let's start this one. This ordered pair is going to be 0, 4, right? Because you don't go over any and it's up at 4. And I'm going to pick this ordered pair, which is at -4. And then it's also down at -4. So let's do this. Let's find this slope. We do it the exact same way. I got an x1 and a y1. Again, I could have labeled this x2, y2. It doesn't make a difference. I'm going to do this one x2, y2. So my formula, y2, 4 minus y1, which is -4, over x2, which is 0, minus x1, which is -4. So on top, I get 8. On bottom, I get 4. Last step, divide those. 8 divided by 4 is 2. Now, I'm going to kind of explain what in the world we're actually finding because it's pretty clear on this graph. To turn any whole number into a fraction, you can put a 1 under it, right? And if you remember on the second slide, we said that slope was also rise over run. So what we have really found is that to get from this dot to this dot, 2 consecutive dots, you go up 2, because that's my rise, and over 1, because that's my run. And we could do it again. Rise 2, go over 1. And look, we're at the next dot. Rise 2, go over 1. We're at the next dot. Rise 2, go over 1. We're at the next dot. So that's really what this slope is. It's telling us how many up and how many over to go so that we can connect these dots and make a line. All right, let's do another graph. Again, we just want some points that cross at the grid. So look at this. I'm going to point out a few for you. First one I see right away is this one. It crosses at 0, 4. Another one I see is this one. I like to use intercepts if it's possible because intercepts are easy. This intercept is at 1, 2, 3, 4, 5, 0. We could also have used this point because it crosses at the grid. This is at -5, and then it's up at 8. Any of those would work. Again, I'm going to use my intercepts just because I like intercepts. So I'm going to do x1, y1, x2, y2. Formula y2 minus y1 over x2 minus x1. So I get -4 on top and 5 on bottom. Last step, divide those. -4 divided by 5. Change it to a fraction, hit math, enter, enter, and it just reduces to -4/5. All right, I'm going to let you guys try this one. Find a slope. Actually, wait, time out, because I want to do this. I want to show you this rise over run also. So remember, it's rise over run, and I got -4 over 5. So all that means is if I want to go from this dot to this dot, that means I'm going to go down 4. 1, 2, 3, 4. And it's down because it's negative. I want to go over 5. 1, 2, 3, 4, 5. And I'm at this dot. And I could do it again. Down 4 and over 5 gets me to this dot. So that's what we're talking about with slope. So let's do this one. Intercepts again. I love intercepts. I'm going to use this one, which is at 0, 2. I'm going to use this one, which is at 1, 0. Some other points, if you were looking at it and you're like, well, couldn't I use that? You could use this one, or this one, or this one, or this one, or this one. But again, I like intercepts, so that's what I'm going to use. So x1, y1, x2, y2. Formula, y2 minus y1 over x2 minus x1. So I get negative 2 over 1. Divide those and you get negative 2. That's my slope. And again, if I want to turn it to a fraction, that means down 2 over 1, which is my slope. Down 2 over 1, down 2 over 1, down 2 over 1. Okay, let's do I think this is our last graph. Nope. Oh, yeah. Okay, I'm going to skip this graph because I think we're good. I do want to show you one quick way. I see that it passes here and here. I could do my ordered pairs just like we've been doing. Or, if you're really good and you can rely on yourself, we could do rise over run and not even really do any mathematical equation. You go up 2, that's your rise. And you go over 1, that's your run. And 2 divided by 1 is 2. So this slope of this graph is 2. I'm going to go ahead and prove it just because this ordered pair was at 1, negative 1. This ordered pair was at 0, negative 3. So y2 minus y1 over, this should be a 3, over x2 minus x1. So on top I get negative 2. On bottom I get negative 1. Negative 2 divided by negative 1 is 2. So either way works. You can find points and do it that way, or do rise over run. Real quick refresher from the second or third slide, I can't remember. If it's a horizontal line, no need to even do the slope. The slope is 0. If it's a vertical line, the slope is undefined. Horizontal is 0, vertical is undefined. Okay, tables. How in the world do you find the slope of a table? It's actually super easy. Tables just give you ordered pairs, right? This ordered pair is 0, 1. This ordered pair is 1, 2. Guess what? We do it the exact same way. I'm going to write the ordered pairs down here. I got 0, 1. That's my first ordered pair. And I got 1, 2. That's my second ordered pair. So just like before, I got an X and a Y. I'm going to put 1s. I got an X and a Y. I'm going to put 2s. My formula is y2 minus y1 over x2 minus x1. 2 minus 1 is 1. 1 minus 0 is 1. 1 divided by 1 is 1. Now, does it matter if you pick the first 2 ordered pairs or if you pick the first and last or the last 2? It doesn't matter. So like here, I'm going to pick this one. I'm going to pick 2, 14. I'm going to label it x1 and y1. And I'm going to pick the very last one. I'm going to pick 8, 38. And again, x2, y2. So formula is going to be y2 minus y1 over x2 minus x1. 38 minus 14 is 4, nope. $38 minus 14 is 24. 8 minus 2 is 6. Last step is to divide those, and you get 4. So the slope of that table is 4. Okay, I'm going to use this first one, and I'm going to use the middle one, just because I got x1, y1, x2, y2. So y2 is 3, y1 is 1, x2 is negative 5, x1 is negative 5. On top I get 2. On bottom, negative 5 minus negative 5 is 0. Again, if you try and divide that, 2 divided by 0, it comes up as an error. This slope is undefined. because 0 is on the bottom. And that will get you through this worksheet that you're about to do. Just kidding. We're going to do one more thing. We're going to find out if the rate of change is constant. Okay. So sometimes when you're given a table, they're not going to tell you that it's linear, that you're going to get the same thing. So we have to find the rate of change for each number. Okay. And I'm going to show you how to do that. It's pretty easy. We did it before trying to figure out if it was linear or not. So to get from 0 to 1, we add 1. 1 to 2, we add 1. 2 to 3, we add 1. 3 to 4, we add 1. To get from 1 to 4, we add 3. To get from 4 to 5, we add 1. To get from 5 to 8, we add 3. 8 to 11, we add 2. Well, all my x's were the same, right? I got 1. All my y's, was that rate of change the same? No, it wasn't. I got 3 and then 1 and then 3 and then 2. So is the rate of change constant? No. And we're just going to stop. We did not get the same numbers on both sides. Let me show you while we're doing this what would have happened here. Well, let's just wait. Okay, let's do this one. 0 to 1, go up by 1. 1 to 2, we go up by 1. 2 to 6, we go up by 4. 6 to 8, we go up by 2. Now, we can't just stop here and say, oh, they're different. Okay, we got it, and I'm going to show you why. To get from 8 to 6, we go up by 2. 8 to 10, we go up by 2. 10 to 18, we go up by 8. 18 to 22, we go up by 4. Okay, so here's the big deal, why we couldn't. My x's are all different, right? I got 1, 1, 4, 2. But so are my y's. My y's went 2, 2, 8, 4. Now, if they're both different, if the x's and the y's are different, then we're actually going to have to divide them. And if you remember, your slope is your change in y over your change in x. So I'm going to do that for all of these. Okay, here are my change in x's. Here are my change in y's. And I'm going to divide them. So I'm going to take these very first two. 2 divided by 1 is 2. I'm going to do the same thing with the next pair. 2 divided by 1 is 2. I'm going to do the same thing with my next pair. 8 divided by 4, because it's y divided by x, is 2. And last, I'm going to do these bottom ones. 4 divided by 2 is 2. So after I divided all of them, did I get the same answer? Yes. I got 2, I got 2, I got 2, I got 2. So is the rate of change constant? Yes. If so, what is it? It is 2. Okay? So let's recap, because I want to make sure we're not really confused. Here, I stopped and said no, because all of my x's were the same, but all of my y's were not. Okay? So if your y's are not the same, but your x's are, then you can already say no, it's not constant. But on this problem, because my x's were different and my y's were different, I had to actually do that division to see if it would come out even. Okay? Let's do another one. 8 to 12 means you go up 4. 12 to 16, you go up 4. 16 to 20, we go up 4. 20 to 24, we go up 4. Okay, all my x's were the same. We went up 4. Well, let's do these. 7 to 5, we went down 2. 5 to 3, we went down 2. 3 to 0, we went down 3. 0 to negative 2, we went down 2. So, all of my x's were the same. They were all up 4. All my y's were not the same. So, is it constant? No. And we don't need to divide it because all my x's were the same, but my y's were not. Okay, this one is a little bit different. It doesn't say is it the same? It's saying which interval has the greatest rate of change. So let's figure it out. This is 1, 1, 1, 1. We're going up by 1 each time. Okay, let's do these. 60 to 50, we went down 10. 50 to 25, we went down 25. 25 to 80, we went up 55. 80 to 65, we went down 15. 65 to 65, we didn't change any. 65 to 65, we didn't change any. 65 to 50, we went up 15. And then remember, we're always going to divide. So I'm going to take these, and it's y divided by x. So it's negative 10 divided by 1 is negative 10. Here, I'm going to do negative 15, or sorry, that's a 25. Negative 25 divided by 1 is negative 25. Here, I got 55 divided by 1, which is 55. Hopefully you see a pattern. We're just going to keep dividing by 1, so we're going to get the exact same number. So which interval had the greatest rate of change? Which number was the biggest? Now, one thing you need to take note of is we don't care about negatives. We just want the biggest number. So out of 10, 25, 55, 15, 0, 0, and 15, which is the biggest number? 55. So which interval had the biggest rate of change? It's this interval right here. Let me do it in red. This interval. From hours 2 to 3, that's our biggest rate of change. We went up by 55. All right, here's another one. All of these, again, are going up by 1s. Up by 1, up by 1. Here I go up 25. Here I go up 25. Here I go up 25. Here I go up 35. Here I go up 30. Here I go up 40. Biggest rate of change means we're going to divide, but look, what am I going to divide by each time? 1, right? So I'm going to get the exact same number. So this is another one I can kind of skip the division part and just say which of these is the biggest? 25, 25, 25, 35, 30, or 40? Right here is the biggest between hours 5 and 6 because it went up by 40. That's your biggest rate of change. So now if you will go try that worksheet and let me know if you need help.